Hi, welcome back to my class in Plane Trigonometry. For today, we will take up the values of the 6 trigonometric functions of the special angles. The special angles are 30 degrees, 45 degrees, and 60 degrees. And these three angles are known as special angles because they frequently appear or they frequently occur in many applications and problems, and mostly in higher mathematics courses. So we start with the trigonometric functions of the special angle 45 degrees. The values of the 6 trigonometric functions of the special angle 45 degrees are obtained from the isosceles right triangle. An isosceles right triangle is a right triangle, which means that one of its angles is fixed at 90 degrees and it is a right angle. And the sides of this isosceles right triangle that form the right angle are congruent, which means that their measures are equal. Consider this triangle. This is an isosceles right triangle. It is a right triangle because one of its three angles is a right angle, which means that the measure of this angle is 90 degrees, and it is a right angle as indicated by this square. And this side of this triangle that form the right angle are congruent. This side of this right triangle and this side of this right triangle are congruent, which means that their measures are equal. If we denote this by A and we denote this by B, and if this side and this side are congruent, then A equals B. And so this is an isosceles right triangle. It's a right triangle. One of the angles is fixed at 90-degree angle, and the two sides, the sides of the right triangle that form the right angle are congruent or equal. And the hypotenuse remains the longest side among the three sides of the triangle. And to derive the trigonometric functions of 45 degrees. Now, there is a property from geometry that if two sides of a triangle are congruent, then the angles opposite them are also congruent. The angle opposite side B is this angle. If we denote this by angle theta, and the side opposite this side of the right triangle is the angle opposite this side of the right triangle is this angle, and we denote this by theta. And from a theorem in your course in geometry, the angles opposite the congruent sides of a triangle are also congruent. Hence, this angle and this angle are equal. So by triangle sum theorem, if we add these two angles, theta plus theta, plus this right angle whose measure is 90 degrees. By triangle sum theorem, the sum of the three angles of a triangle is 180 degrees. Theta plus 90 is 180 degrees. Now we find the value of theta from this equation. From algebra, theta plus theta is equal to 2 theta. And we transpose 90 degrees to the right hand side. We take the opposite side of 90. 2 theta equals 180 degrees. Positive 90 degrees we transpose to the right, we get negative minus 90 degrees. And we have 2 theta at the left side. equals 180 minus 90 equals 90 degrees. Finally, to solve for theta, we divide both sides of this equation by 2. We divide 2 theta by 2. And we divide 90 degrees by 2. And 2 will cancel out from the left hand side. We get theta equals 90 divided by 2 is 45 degrees. 90 divided by 2 is 45 degrees. So this angle is 45 degrees and this angle is 45 degrees. And again, from a theorem in your course in geometry, the angles opposite, the sides opposite the congruent angles are also congruent. The side opposite this angle theta is A, the side opposite this angle theta is B, and they are also congruent. Also, the sides, the angles opposite the congruent sides, this side A and this side B are congruent. The angles opposite them are also congruent. The angle opposite A is theta, and this theta is equal to the angle opposite B, which is also theta, and these angles are each 45 degrees. And we will derive the values of the 6 trigonometric functions of 45 degrees. The longest side is the of this isosceles right triangle is the side opposite the right angle, and we call it hypotenuse. And we let the side of the hypotenuse be equal to 1 unit. We let the length of the hypotenuse, the side opposite the right angle, be equal to 1 unit. And with our knowledge that A equals B and C equals 1, we find the value of A and B using Pythagorean Theorem. By Pythagorean Theorem, the sum of the squares of the lengths of a right triangle is equal to the square of the hypotenuse. Or the Pythagorean Theorem states that the square of the hypotenuse, C squared, is equal to the sum of the squares of the two other sides. The two other sides being the legs of the right triangle, A squared plus B squared. The square of the hypotenuse C is equal to the sum of the square of A and the square of B. But we let C be equal to 1 equals A squared, and because this is an isosceles right triangle, two of its sides are equal or congruent, so B equals A or A equals B. We replace B with A in this equation, replace B with A. At the left hand side we have 1, and addition of algebraic expression A squared plus A squared. The numerical coefficient here is 1, the numerical coefficient here is 1. And we add the numerical coefficient 1 here plus 1 here is 2. And we copy the common literal coefficient A squared. Now we divide both sides of the equation by 2 because we are solving for A. We want the coefficient of A squared equals 1. We divide the left side by 2, we divide the right hand side by 2, and 2 will cancel out from the right hand side. We get A squared is equal to 1/2. Finally, we take the root of both sides to solve for A. A is equal to, by property of radical, the square root of 1/2 is equal to the square root of 1. Divide by the square root of 2. And the square root of 1 is 1. And the square root of 2 is not an integer. So we simply write the square root of 2. So this is the value of A, 1 over square root of 2. And this is also the value of B. Or you can rationalize the denominator by multiplying the numerator and denominator by square root of 2. Now we are ready to find the values of the 6 trigonometric functions of the special angle 45 degrees. We start with sine of 45 degrees. As we defined in the past lesson, sine, the value of sine of an angle, of an acute angle, is equal to the ratio of the side opposite the angle divided by the hypotenuse. And the side opposite the acute angle 45 degrees is A, whose value is 1 over square root of 2. Hence, the sine of 45 degrees is opposite A, whose value is 1 over square root of 2. Divide by the hypotenuse. And the hypotenuse, we let it be equal to 1. Or sine of 45 degrees. 1 over square root of 2 divided by 1 is 1 over square root of 2. Now I will rationalize the denominator. We multiply numerator and denominator by square root of 2. To rationalize the denominator is to remove the radical sign from the denominator. That's why we multiply the numerator and denominator by square root of 2. In the numerator, we have 1 times square root of 2 is equal to square root of 2. And in the denominator, we have square root of 2 times square root of 2 by property of radicals. Square root of 2 times square root of 2 can be written as a single radical with whose index is the common index. The common index here is 2. For square root, the index is 2. Square root of 4. We multiply the radicals. 2 by 2 equals 4. And the square root of 4 is 2. Hence, the sine of 45 degrees equals the square root of 2 divided by 2. Now, we find the value of the cosine of 45 degrees. From our past lesson, the cosine of an acute angle is equal to the ratio of the adjacent side and the hypotenuse. Hence, cosine of 45 degrees equals adjacent. The cosine of 45 degrees is equal to the side adjacent to the acute angle 45 degrees and divided by the hypotenuse. And here in this diagram, the side adjacent to this acute angle 45 degrees is B, whose like is also equal to 1 over square root of 2. We replace adjacent side equals 1 over square root of 2. And divide by the hypotenuse. The hypotenuse, we take it as 1. And you can see that the sine of 45 degrees, 1 over square root of 2 divided by 1 is the same as the cosine of 45 degrees, 1 over square root of 2 divided by 1. And if we simplify this, we would also get square root of 2 over 2. Hence, the cosine of 45 degrees equals the sine of 45 degrees square root of 2 divided by 2. This can be obtained from here, but this is the same as this expression which we have already simplified. And the process for simplifying this is similar to this process. 1 over square root of 2 divided by 1 is 1 over square root of 2. And we want to remove the radical sign from the denominator. We multiply numerator and denominator by square root of 2 and square root of 2. 1 times square root of 2 equals square root of 2. Square root of 2 times square root of 2 written as a single radical is equal to square root. Square root, because the common index here is 2. For square root, the index is 2. In these two radicals, the common index is 2. And we have square root of the product of the radicals. 2 multiplied by 2 is 4. But square root of 4 is 2. So we have square root of 2 divided by 2. And that's the same value of cosine of 45 degrees. Now we will derive the tangent of 45 degrees. We now obtain the value of the tangent of 45 degrees. The tangent of 45 is, as we have taken in the previous lesson, the tangent of an acute angle is equal to the ratio of the side opposite the acute angle and the side adjacent to the acute angle. For the tangent of 45 degrees, it is equal to the ratio of the side opposite the acute angle 45 degrees and the side adjacent to 45 degrees. And the side opposite 45 degrees is A, whose value or length is 1 over square root of 2. Divide by the side, the length of the side adjacent to 45 degrees. Adjacent to 45 degrees is this side of the isosceles right triangle, whose length B is equal to 1 over square root of 2. And 1 over square root of 2 divided by 1 over square root of 2, or this quantity divided by the same quantity is equal to 1. Thus, the tangent of 45 degrees is 1. The values of the last three trigonometric functions of 45 degrees are obtained from the values of the first three trigonometric functions of 45 degrees. We know that cosecant is the reciprocal of sine. Hence, the value of cosecant of 45 degrees is the reciprocal of the value of sine of 45 degrees. The sine of 45 degrees is equal to square root of 2 divided by 2 as we have shown. And this was derived from the original value of 1 over square root of 2, the original value of sine of 45 degrees. Hence, the cosecant of 45 degrees is the reciprocal of this value of sine of 45 degrees. And the reciprocal of 1 over square root of 2 is square root of 2 over 1. And square root of 2 divided by 1 is square root of 2. We know that secant is the reciprocal of cosine. Thus, the value of the secant of 45 degrees is the reciprocal of the value of cosine of 45 degrees, which is equal to square root of 2 over 2, which was derived from the original value of 1 over square root of 2 of cosine of 45 degrees. And so the secant of 45 degrees is the reciprocal of 1 over square root of 2, the value of cosine of 45 degrees. And the reciprocal of 1 over square root of 2 is square root of 2 over 1, or square root of 2 divided by 1, which gives us square root of 2. And cotangent is the reciprocal of tangent. Thus, the value of cotangent of 45 degrees is the reciprocal of the value of tangent of 45 degrees, which is 1. And the reciprocal of 1 is 1. These are the values of the 6 trigonometric functions of 45 degrees. The sine of 45 degrees is equal to square root of 2 divided by 2. Cosine of 45 degrees equals square root of 2 divided by 2. Tangent of 45 degrees is 1. Cosecant of 45 degrees equals square root of 2. Secant of 45 degrees equals square root of 2. And cotangent of 45 degrees equals 1. Now, we take an example for using these functions 45 degrees. Now, 45 degrees, if you will plot this as a positive angle in standard position, you will find 45 degrees in the first quadrant of the Cartesian plane. What if the given angle is a multiple of 45 degrees and that angle lies in the second, third, or fourth quadrant? What would be the values of the 6 trigonometric functions of that angle that is a multiple of 45 degrees and whose terminal side lies in the second, third, or fourth quadrant? We take an example. Take an example, find the values of the functions of 315 degrees. 315 degrees is divisible by 45 degrees. If you divide 315 degrees by 45 degrees, and you will get 7. So there are 7 45-degree angle in 315 degrees. 7 will be our guide in plotting 315 degrees in standard position in the Cartesian plane. If we draw 315 degree, the angle 315 degrees in standard position, the vertex should be at the origin. And the initial side is at the positive x-axis. And 315 degrees contains 7 45-degree angle. And one quadrant has 2 45-degree angle. So we count 7 45-degree angle from the positive x-axis. This quadrant has 2 45-degree angle. This second quadrant has 2. So that's already 2 plus 2, 4 45-degree angle. And this third quadrant has also 2 45-degree angle. That's 2, 4, 6. And we only need another 1 45-degree angle. in the fourth quadrant. This is the terminal side of the given angle 315 degrees. It's measured from the positive x-axis, from its initial side on the positive x-axis in counterclockwise direction. And this is the last of the 7 45-degree angle, which means that this angle is also 45 degrees. Now we take a point on the terminal side of the angle 315 degrees. Say this point, and from this point we drop a perpendicular to the x-axis to construct a right triangle. We take an arbitrary point on the terminal side of the given angle 315 degrees, and from this point we drop a perpendicular to the x-axis to construct a right triangle. And this is also 45 degrees. The trigonometric functions now of 315 degrees are equal to the trigonometric functions of 45 degrees in this right triangle. And if this is 45, this is also 45 degrees. And the sides opposite these two 45-degree angles are also congruent. Hence, this right triangle is an isosceles right triangle. The side opposite the right angle is 1. This is 1. And the congruent sides of an isosceles right triangle, if the hypotenuse is 1, are 1 over square root of 2 and 1 over square root of 2. Hence, this is 1 over square root of 2. And this is 1 over square root of 2. Which means that the coordinates of this point, its x is 1 over square root of 2. The abscissa of this point on the terminal side of 315 degrees is 1 over square root of 2. And the ordinate y, since this point is on the fourth quadrant, it is below the x-axis, the value of y is negative. The negative of 1 over square root of 2. So we write negative. The value of the ordinate of the point on the terminal side of 315 degrees is negative 1 over square root of 2. But the length of this side of this isosceles right triangle is positive 1 over square root of 2. The negative here indicates only that the point is below the x-axis. Now we are ready to write the 6 trigonometric functions of 315 degrees. We start with the side of 315 degrees. Using this diagram as our reference, the sine of an angle is the ratio of the side opposite the angle, y, over the hypotenuse, which is the radius vector, denoted by r. The radius vector r is the distance of the point on the terminal side of the angle 315 degrees from the origin, and we take that radius vector as 1 for the special angle 45 degrees. And the congruent sides are equal to 1 over square root of 2 and 1 over square root of 2. So the sine of 315 degrees equals the side opposite 45 degrees, y, divided by the radius vector r. And y is equal to negative 1 over square root of 2 divided by the radius vector 1, which gives us negative 1 over square root of 2. And we want to remove the radical sign from the denominator. So we rationalize the denominator by multiplying numerator and denominator by square root of 2. And the sign is still negative. 1 times square root of 2 is square root of 2. Divided by square root of 2 times square root of 2 can be written as a single radical, with whose index is the common index of square root of 2 and square root of 2, which is 2. And the radicand is the product of the radicands 2 and 2. So square root of 2 times square root of 2 is equal to square root of 4. But the square root of 4 is 2. Thus, the sine of 315 degrees is equal to negative square root of 2 divided by 2. The sine of 315 degrees equals negative square root of 2 over 2. Next, we find the cosine of 315 degrees. By definition of cosine of an angle, its value is equal to the ratio of the side adjacent to 45 degrees. In this diagram, it is x divided by the hypotenuse, the radius vector r. And x is 1 over square root of 2 divided by the radius vector 1. 1 over square root of 2 divided by 1 is 1 over square root of 2. Again, we want to remove the radical sign from the denominator. We rationalize the denominator by multiplying numerator and denominator by square root of 2. Multiply the numerator, 1 times square root of 2 is square root of 2. Divide by square root of 2 times square root of 2, as by property of radical is equal to square root of 4. Why square root of 4? The common index of square root of 2 and square root of 2 is 2. So in the product of square root of 2 times square root of 2, the index of the radical sign is the common index 2. And the radicand is the product of the radicands 2 and 2. So square root of 2 times square root of 2 is equal to square root of 4, which is 2. Thus, the cosine of 315 degrees is positive square root of 2 divided by 2. Next, we find the tangent of 315 degrees. Tangent from our past lesson is equal to the ratio of the side opposite the angle. And in our diagram, the side opposite 45 degrees is y, over the side adjacent to 45 degrees, x. And our y, the value of y is negative 1 over square root of 2. Divide by x, the value of x is positive 1 over square root of 2. And we have negative, divide by positive is negative. And this quantity, 1 over square root of 2, divided by the same quantity, 1 over square root of 2, is 1. Hence, the tangent of 315 degrees is negative 1. And the values of the last three trigonometric functions of 315 degrees are the reciprocal of the values of the first trigonometric functions of 315 degrees. The value of cosecant of 315 degrees is the reciprocal of the value of sine of 315 degrees, which is equal to negative square root of 2 divided by 2. But negative square root of 2 divided by 2 came from the original answer, original value of sine of 315 degrees. Instead of getting the reciprocal of negative square root of 2 over 2, we get the reciprocal of the original value of sine of 315 degrees, negative 1 over square root of 2. Because if we take the reciprocal of this, negative square root of 2 over 2, we still have to rationalize the denominator, and that would require additional steps to find the value of cosecant of 315 degrees. Whereas if we take the reciprocal of the original value of sine of 315 degrees, which is equal to negative 1 over square root of 2, the reciprocal of this would not contain a radical sign in the denominator. The denominator would be 1. And the reciprocal of negative 1 over square root of 2 is still negative. Reciprocal of 1 over square root of 2 is square root of 2 over 1. And square root of 2 divided by 1 is square root of 2. The value of the secant of 315 degrees is the reciprocal of the value of cosine of 315 degrees, whose value is positive square root of 2 over 2. But this value of square root of 2 over 2 for cosine of 315 degrees came from the original answer of 1. The original value of cosine of 315 degrees is 1 over square root of 2. And the secant of 315 degrees is equal to the reciprocal of the original value of cosine of 315 degrees. The secant of 315 degrees is the reciprocal of 1 over square root of 2, which is square root of 2 over 1. And square root of 2 divided by 1 is square root of 2. The cotangent of 315 degrees is the reciprocal of the value of the tangent of 315 degrees, which is equal to negative 1. And the reciprocal of negative 1 is negative 1. These are the values of the 6 trigonometric functions of 315 degrees. Sine of 315 degrees equals negative square root of 2 over 2. Cosine of 315 degrees equals square root of 2 over 2. Tangent of 315 degrees equals negative 1. Cosecant of 315 degrees equals negative square root of 2. Secant of 315 degrees equals square root of 2. And cotangent of 315 degrees equals negative 1. Again, if there is an angle like 315 degrees that is a multiple of 45 degrees, and you want to find the values of the six trigonometric functions of such an angle that is a multiple of 45 degrees, divide that angle by 45 degrees for you to find how many 45-degree angle are there in the given angle. Like 315 degrees, we divide by 45 degrees and we obtain 7, which means that there are 7 45-degree angle in 315 degrees. And the use of that 7 is for us to construct the given angle 315 degrees in standard position with vertex at the origin and initial side on the positive x-axis. And from the initial side, we count 7 45-degree angle. And we said that each quadrant has 2 45-degree angle. So this is 2 and 2 and 2. That's 6 45-degree angle, and we need an additional 45-degree angle. And this is the terminal side of the given angle 315 degrees. If this is 45 degrees, because this quadrant has 90 degrees, if this is 45 degrees, then this is also 45 degrees. From the terminal side of the given angle, you take an arbitrary point, and from the point on the terminal side of the given angle, you drop a perpendicular to the x-axis to construct an isosceles right triangle. And the distance of the point on the terminal side of the angle from the origin is the radius vector. And for the isosceles right triangle with two 45-degree angle, we take the radius vector as 1. And the two congruent sides of the isosceles right triangle are each equal to 1 over square root of 2 and 1 over square root of 2. The value of y here happens to be negative because the point on the terminal side of the given angle 315 degrees is below the x-axis, and the ordinates of the points below the x-axis are negative. Now we find the trigonometric functions of the given angle 315 degrees in terms of the trigonometric functions of the special angle 45 degrees. Now we will derive the functions of 30 degrees and 60 degrees. We now derive the values of the six trigonometric functions of the special angle 60 degrees and 60 degrees, 30 degrees and 60 degrees. The values of the six trigonometric functions of the special angles 30 degrees and 60 degrees are derived from equilateral triangle. If we derive the values of the six trigonometric functions of the special angle 45 degrees from an isosceles right triangle, we derive the values of the six trigonometric functions of the special angles 30 degrees and 60 degrees from an equilateral triangle. An equilateral triangle is also an equiangular triangle, which means that an equilateral triangle has two properties. All of its three sides are congruent, which means that all of the three sides have the same measure, and all of its three angles are congruent also, which means that all the three angles have the same measure. We consider the following equilateral triangle. This triangle is an equilateral triangle. So these three sides of this triangle are congruent. And to simplify the derivation of the functions of the special angles 30 degrees and 60 degrees, we let the length of each of these three sides of equilateral triangle be equal to 1 unit. And this equilateral triangle is also an equiangular triangle, which means that the three angles opposite the three congruent sides are also congruent. So if these three angles are congruent, they have the same measure. If we denote this angle by theta, then these two angles are also theta because they are congruent, they have the same measure. And by triangle sum theorem, if we add these three angles denoted by theta, we get theta plus theta plus theta. And the sum of the three angles denoted by theta must be 180 degrees by triangle sum theorem. And from your course in algebra, theta plus theta plus theta is equal to 3 theta equals 180 degrees. And we divide both sides by 3. We divide the left side by 3. We divide the right hand side by 3. And 3 will cancel out from the left hand side because 3 over 3 is 1. So we are left with theta at the left hand side. At the right hand side, 180 divided by 3 is 60 degrees. This means that the measure of each of these three congruent angles is 60 degrees. This is 60 degrees. Now, to construct a right triangle, we drop from each vertex of these three. From a vertex of one of the three congruent angles, we drop a perpendicular to the opposite side. We consider this vertex of this angle. From this vertex, we drop a perpendicular to the opposite side. This is the side opposite this angle. And from the vertex of this angle, we drop a perpendicular to this side of the right triangle, the side opposite this, and that perpendicular line to the opposite side will pass through the midpoint of the opposite side. This is the midpoint of this side opposite this angle, and from this vertex we drop a perpendicular passing through the midpoint of the opposite side. Because this line is perpendicular to this side of the equilateral triangle, they form a right angle. Now the length of this side of equilateral triangle is 1 unit. And because this point is a midpoint, it divides the length of this side of equilateral triangle into 2 equal parts. If this length is 1 unit, then half of 1 unit is 1/2. Hence, the length of this side of this right triangle is 1/2. And from the midpoint to this vertex is also 1/2. Considering this right triangle, this is 60 degrees and this is 90 degrees, and we want the measure of this angle. This perpendicular line is also a bisector of this angle, which is 60 degrees. If this line bisector of the opposite side is also a bisector, angle bisector of 60 degrees. This line divides this angle 60 degrees into 2. 60 divided by 2 is 30 degrees. It is from this right triangle with acute angles 30 degrees, 60 degrees that we will find the values of the trigonometric functions of 30 degrees and 60 degrees. Now, we only have one length of the right triangle unknown, this side. And we find the length of this side by Pythagorean Theorem. The Pythagorean Theorem says that the square of the hypotenuse, the side opposite the right angle, whose length is 1, the square of 1, is equal to the sum of the squares of the two other sides. The two other sides are the sides of the right triangle that form the right angle. The length of this side is 1/2. the square of 1/2, the square of 1/2 plus the square of this side, we denote this by x, plus the square of x, x squared, is equal to square of 1. This is from Pythagorean Theorem that says the square of the hypotenuse has a length of 1, the hypotenuse is the side opposite the right angle, is equal to the sum of the squares of the two other sides. The two other sides have lengths of 1/2 and x. And from this equation, we can now solve for x. The square of 1 is 1, equals the square of 1/2 by property of exponent from your course in algebra is equal to the square of 1, which is 1. Divide by the square of 2, which is 4, plus x squared. And we transpose 1/4 to the other side of the equation, and we take the opposite sign of 1/4. At the right hand side, we have x squared. X squared is equal to 1. Transpose positive 1/4 to the left hand side, we have minus 1/4. And the denominator of 1 here, if you will write, the denominator of 1 is 1. And the lowest number that is divisible by 4 and 1 is 4. And we call that number LCD, or lowest common denominator. We now have x squared equals a fraction with lowest common denominator of 4, and we find the numerator. We divide each, we write the denominator of 1, it's 1. We divide the lowest common denominator by each denominator of the fractions we are combining, and we multiply the quotient by the numerator of each fraction. 4 divided by 1 is 4, multiplied by 1 is 4. Minus LCD 4 divided by 4 is 1, multiplied by the numerator 1 is 1. X squared now is equal to 4 minus 1 is 3, divided by 4. And we extract the root of both sides to find the value of x. The square root of x squared at the left hand side is x. At the right hand side, by property of radical, the square root of 3 over 4 is equal to the square root of the numerator 3, square root of 3. Divide by the square root of the denominator 4. The square root of 4 is 2. Therefore, the side of this right triangle is square root of 3 over 2. Now we are ready to find the values of the trigonometric functions of 30 degrees, and we start with sine of 30 degrees. From our past lesson, the value of sine of an acute angle is equal to the ratio of the side opposite the acute angle and the hypotenuse. And the side opposite 30 degrees is the acute angle 30 degrees, and opposite side is this with the length of 1/2. Divide by the hypotenuse is 1. And 1/2 divided by 1 is 1/2. Therefore, the sine of 30 degrees is 1/2. Next, we find the cosine of 30 degrees. The cosine of an acute angle from our previous lesson is defined as the ratio of the sine adjacent to the acute angle and the hypotenuse. Or cosine of 30 degrees equals adjacent side over the hypotenuse. And this 30 degrees, the side of this right triangle that makes the angle 30 degrees with the hypotenuse is this side, whose length is x, whose length is denoted by x and has a value of square root of 3 over 2. Adjacent side, the side adjacent to 30 degrees has a length of square root of 3 over 2. Divide by hypotenuse, the hypotenuse is 1. Square root of 3 over 2 divided by 1 equals square root of 3 over 2. Thus, the cosine of 30 degrees is square root of 3 over 2. Now we find the tangent of 30 degrees. The tangent of an acute angle from our past lesson is defined as the ratio of the side opposite the acute angle and the side adjacent to the acute angle, or tangent of 30 degrees equals opposite side divided by adjacent side. From our diagram, the side opposite 30 degrees has a length of 1/2. Divide by the adjacent side. The side adjacent to 30 degrees, which is this side denoted by x, has a length of square root of 3 over 2. And we simplify this complex fraction by multiplying the numerator 1/2. Multiply 1/2 by the reciprocal of the denominator, square root of 3 over 2. Its reciprocal is 2 over square root of 3. And you can see 2 will cancel out. And we get 1 over square root of 3. And to remove the radical sign from the denominator, we rationalize the denominator, or we rationalize square root of 3 by multiplying 1 by square root of 3 and multiplying the denominator square root of 3 by square root of 3. We multiply the numerators. 1 multiplied by square root of 3 is square root of 3. Square root of 3 times square root of 3 can be written as a single radical equal to the square root of 3 multiplied by 3 is 9. Square root of 3 times square root of 3 equals square root of 9. Why square root? Because the common index between square root of 3 and square root of 3 is 2. For square root, the index is 2. And by property of radical, if you are multiplying radicals with common indices, then it's equal, can be written as a single radical whose index is equal to the common indices of the two radicals you are multiplying, and the radicand is the product of the radicands 3 and 3. Square root of 3 multiplied by square root of 3 is equal to square root of 9. And square root of 9 is 3. Thus, the tangent of 30 degrees equals square root of 3 over 3. The values of the next three, the last three of the 6 trigonometric functions of 30 degrees have values equal to the reciprocals of the values of the first three functions of 30 degrees. The reciprocal of sine is cosecant of 30 degrees. The value of cosecant of 30 degrees is the reciprocal of the value of sine of 30 degrees. Because the reciprocal of sine is cosecant. The value of cosecant of 30 degrees is equal to the value of the reciprocal of the value of sine of 30 degrees. Again, the value of cosecant of 30 degrees is equal to the reciprocal of the value of sine of 30 degrees, which is equal to 1/2, and its reciprocal is 2 over 1, or 2 divided by 1 is 2. The reciprocal of cosine is secant. So, reciprocal of cosine 30 degrees is secant of 30 degrees. And the value of the secant of 30 degrees is the reciprocal of the value of cosine of 30 degrees, which is equal to square root of 3 over 2. The value of cosine of 30 degrees equals square root of 3 over 2. And its reciprocal is 2 over square root of 3. The reciprocal of the value of cosine of 30 degrees is 2 over square root of 3. And we want to remove the radical sign from the denominator. So we multiply the numerator 2 by square root of 3. We also multiply the denominator square root of 3 by square root of 3. And we get 2 times square root of 3 is 2 times square root of 3. In the denominator, we have the square root of 3 times square root of 3 can be written as a single radical by property of radical as square root of 9. 9 is obtained by multiplying 3 by 3. And square root is, we use square root because the common index between these two radicals is 2. The index for square root is 2. Hence, square root of 3 times square root of 3 equals square root of 9. And square root of 9 is 3. And this is the value of secant of 30 degrees. 2 times square root of 3 over 3. Finally, we find the value of the reciprocal of tangent, which is cotangent. The cotangent of 30 degrees, the value of cotangent of 30 degrees is equal to the reciprocal of the value of tangent of 30 degrees, which is equal to square root of 3 over 3. Tangent of 30 degrees equals square root of 3 over 3. And this value of tangent of 30 degrees came from 1 over square root of 3 when we rationalize the denominator square root of 3. But we obtained the cotangent of 30 degrees from the original value of tangent of 30 degrees, which is 1 over square root of 3. And the reciprocal of 1 over square root of 3 is square root of 3. Now, the value of cotangent of 30 degrees is equal to the reciprocal of the tangent of 30 degrees, whose original value is 1 over square root of 3. So we take the reciprocal of 1 over square root of 3, which is square root of 3 over 1. And square root of 3 divided by 1 is square root of 3. These are the 6 trigonometric functions of 30 degrees. Sine of 30 degrees is 1/2. Cosine of 30 degrees equals square root of 3 over 2. Tangent of 30 degrees equals square root of 3 over 3. Cosecant of 30 degrees, the reciprocal of sine of 30 degrees is 2. 2 is the reciprocal of 1/2. Secant of 30 degrees equals 2 times square root of 3 over 3. Cotangent of 30 degrees has a value of square root of 3. Now we will take an example for using the functions of 30 degrees. This 30-degree angle, if you plot this in standard position, will be in the first quadrant. If we have an angle that is a multiple of 30 degrees and lies in second or third or fourth quadrant, we find that 6 trigonometric functions of that angle in terms of the trigonometric functions of 30 degrees. If the given angle is a multiple of 30 degrees, which means the given angle is exactly divisible by 30 degrees. For our example, consider the following. Find the 6 trigonometric functions of 150 degrees. 150 degrees is less than 180 degrees. So 150 degrees is an angle in the second quadrant. It is more than 90 degrees, but less than 180 degrees. And we draw the given angle 150 degrees in standard position. So its vertex is at the origin. And the initial side is on the positive side of the x-axis. 150 is divisible by, is a multiple of 30 degrees, which means that 150 degrees is exactly divisible by 30 degrees. We divide 150 by 30 to find how many 30-degree angle is contained in 150 degrees. 150 degrees divided by 30 degrees equals 5, which means that there are 5 30-degree angles in 150 degrees. Now we use this 5 as our reference for constructing the angle 150 degrees. In one quadrant, the angle is 90 degrees. And 90 is divisible by 30. 90 divided by 30 is 3. That means that in each quadrant, there are 3 30-degree angles. In the first quadrant, there are 3 30-degree angles. And 150 degrees is a positive angle. So we measure it from its initial side on the positive x-axis in counterclockwise direction. Again, the first quadrant contains 3 30-degree angles, but we need 5. So we take 2 more 30-degree angles from the second quadrant. And the terminal side would be this. This is from the positive x-axis to the positive y-axis is 90 degrees. Plus 2 more 30-degree angle or 60 degrees. So this is 60 degrees. And from the positive x-axis to this arrow is our given angle 150 degrees. If this is 60 degrees and in one quadrant there are 90 degrees, Then this remaining angle from the terminal side of the angle 150 degrees to this negative side of the x-axis is 30 degrees. 90 minus 60 is 30. Now we have drawn the given angle 150 degrees in standard position. We now construct a right triangle. From the terminal side of the given angle 150 degrees, take an arbitrary point, say this point. And from this point, you drop a perpendicular to the x-axis. And because this line is perpendicular with the x-axis, we have constructed a right angle and a right triangle. From our diagram here, the side adjacent, the hypotenuse, the side opposite the right angle, is taken as 1 unit. And this side opposite the right angle, the hypotenuse, is our radius vector, the distance of this point on the terminal side of 150 degrees from the origin, 1. The side adjacent to 30 degrees has a length of square root of 3 over 2. And the side opposite 30 degrees has a length of 1/2. Now the coordinates of this point on the terminal side of 150 degrees are denoted by x and y, where because this point is in the second quadrant, the value of the abscissa x is negative. The distance of this point from the y-axis is square root of 3 over 2 units. But since the point is to the left of the y-axis, we indicate the distance of this point by writing negative to the value of x. Hence, the abscissa or the x-coordinate of this point on the terminal side of the given angle 150 degrees is square root of 3 over 2 units. This means that the distance of this point from the y-axis is square root of 3 over 2 units. But the point is to the left of the y-axis, indicated by this negative sign. And the ordinate y of this point is equal to 1/2. That is, the distance of this point from the x-axis is 1/2. And y is positive 1/2 because the point is above the x-axis. Now we are ready to find the values of the 6 trigonometric functions of the given angle 150 degrees in terms of the trigonometric functions of the special angle 30 degrees. And we start with sine of 150 degrees. From our past lesson, the sine of an angle is equal to the ratio of the side opposite the angle and the hypotenuse. We find the sine of 150 degrees in terms of the special angle 30 degrees. And 30 degrees is an acute angle. And the side opposite 30 degrees is y. And our hypotenuse is the radius vector, the distance of this point on the terminal side of 150 degrees from the origin, r. And our y has a value of 1/2. And the radius vector is 1. 1/2 divided by 1 is 1/2. Hence, the sine of 150 degrees is 1/2. Now we find the cosine of 150 degrees in terms of the function of the special angle 30 degrees. The cosine function is defined, the value of the cosine function is defined as the ratio of the side adjacent to the angle divided by the hypotenuse. Using this diagram, the side adjacent to 30 degrees is this side of the right triangle, which is equal to x. And the hypotenuse is the radius vector r. But the value of x is negative square root of 3 over 2. Divide by r, the radius. And the radius is 1. Negative square root of 3 over 2 divided by 1 is negative square root of 3 over 2. Thus, the cosine of 150 degrees equals negative square root of 3 over 2. Now, the tangent of 150 degrees The tangent of an angle is defined as the ratio of the opposite side and the adjacent side. And we find the tangent of 150 degrees in terms of the tangent of 30 degrees. The side opposite 30 degrees is y. The side adjacent to 30 degrees is x. And our y has a value of 1/2. Divide by x, our x has a value of negative square root of 3 over 2. And we simplify this complex fraction by multiplying the numerator 1/2 by the reciprocal of the denominators, reciprocal of negative square root of 3 over 2, which is negative 2 over square root of 3. And 2 will cancel out. Now we want to remove the radical sign from the denominator, so we multiply the numerator 1 by square root of 3. And we also multiply the denominator by square root of 3. And we have negative 1 times square root of 3 is negative square root of 3. And by property of radical from your algebra course, square root of 3 times square root of 3 equals square root of 9. And square root of 9 is 3. Hence, the tangent of 150 degrees equals negative square root of 3 over 3. The values of the last three trigonometric functions of 150 degrees can be obtained by taking the reciprocals of the values of the first three trigonometric functions of 150 degrees. The cosine of 150 degrees is equal to the reciprocal of the value of sine of 150 degrees, which is 1/2. And the reciprocal of 1/2 is 2 over 1 or 2. cosecant of 150 degrees is 2. The value of secant of 150 degrees, or simply secant of 150 degrees, is equal to the reciprocal of the value of cosine of 150 degrees. Cosine of 150 degrees is negative square root of 3 over 2. The reciprocal of negative square root of 3 over 2 is the value of secant of 150 degrees. And negative square root of 3 over 2, its reciprocal is negative 2 over square root of 3. Again, we want to remove the radical sign from the denominator. Hence, we multiply the numerator and denominator by square root of 3. Negative 2, we multiply by square root of 3. And the denominator we also multiply by square root of 3. Multiply the numerators, negative 2 times square root of 3 is negative 2 square root of 3. Negative 2 times square root of 3 equals negative 2 times square root of 3. Multiply the denominators by property of radical from your algebra course. Square root of 3 times square root of 3 can be written as a single radical. Square root of 9. 9 is obtained by multiplying the radicals. 3 and 3 is 9. And square root of 9 is 3. The reciprocal again of negative square root of 3 over 2 is the value of secant of 150 degrees. And the reciprocal of negative square root of 3 over 2 is negative 2 over square root of 3. And we want to rationalize square root of 3 in the denominator. We multiply numerator and denominator by square root of 3 and square root of 3. Negative 2 times square root of 3 is negative 2 square root of 3. Square root of 3 times square root of 3 simplifies to 3. And this is the value of secant of 150 degrees. Cotangent of 150 degrees is the reciprocal of the value of tangent of 150 degrees. The tangent of 150 degrees is negative square root of 3 over 3. Here, tangent of 150 degrees is negative square root of 3 over 3, which was obtained from the original value of tangent of 150 degrees equal to negative 1 over square root of 3. Now we get the cotangent of 150 degrees from the original value of tangent of 150 degrees, negative 1 over square root of 3. The reciprocal of negative 1 over square root of 3 is the value of cotangent of 150 degrees. And the reciprocal of negative 1 over square root of 3 is negative square root of 3 over 1. Or negative square root of 3 divided by 1 is negative square root of 3. These are the answers to the problem. The 6 trigonometric functions of 150 degrees. The sine of 150 degrees is 1/2. Cosine of 150 degrees equals negative square root of 3 over 2. Tangent of 150 degrees equals negative square root of 3 over 3. Cosecant of 150 degrees is 2. Secant of 150 degrees equals negative 2 times square root of 3 over 3. And cotangent 150 degrees is equal to negative square root of 3. We obtain negative square root of 3 from the reciprocal of the original value of tangent of 150 degrees, which is equal to negative 1 over square root of 3. Now we will derive the functions of the special angle 60 degrees. Due to lack of time, we will derive the values of the 6 trigonometric functions of the special angle 60 degrees. And also in the next lesson, we will take up the functions of quadrantal angles. For your practice, please do the following exercises. Find the values of the 6 trigonometric functions of each angle given. Draw the diagram. That is, you construct the given angle in the Cartesian plane in standard position, and you construct the right triangle to be shown in the diagram with all the three parts: the adjacent part, the adjacent side, the hypotenuse or radius vector, and the opposite side. Number 1, the given angle is 135 degrees. This is a multiple of 45 degrees. Number 2 is 225 degrees. This is also a multiple of 45 degrees. So for numbers 1 and 2, you follow the example in our first example for multiple of 45 degrees. The given angle number 3 is 210 degrees. This is a multiple of 30 degrees. And in number 4, we have 330 degrees, also a multiple of 30 degrees. For the last two numbers, 3 and 4, you follow the example, our example for an angle that is a multiple of 30 degrees. If you have question about the lesson today, please ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Calizon, the channel of learning and pleasure. Thank you for joining me in my class today.